So this is the recent trend in speech recognitions. Those he is speaking, the machine does not recognize her voice because of the technical problem. Because this is
That's it. That's itself is a speech recognition problem.
yeah. Your voice is recognized, whereas her voice is not recognized.
Yeah.
We are in
Actually,
transition stage, of course. These are all the
she
problems.
is sitting just adjusted to me.
Yeah.
A few boots. I'll check it whether she's
Check
okay.
it out. Is he with you? Is he with you?
She's in the same
Then let
cabin.
her use your
I'll
mic.
just find out.
Yeah, better you could hand over it. Oh, generally in our presentation, there should not be such troubles. These turbulence will disturb us. No, Ganga. Better you could make use of Professor Rajendran's mic and all. I think it doesn't work. It doesn't work since you are sitting nearby. No. I think better avoid the headphone.
Yes, sir.
Yeah.
Better to avoid the headphone. That is good. That one, and to open that one, and the good computer can, laptop can absorb the voice.
No, we don't. Professor Rajendran, are you able to hear her voice? Professor? Is he there? No. Professor Ravishankar?
Yeah.
Is it audible?
Sir, when I was presenting also, the mic was not working. So I presented using laptop mic only.
I see. Better let her, I think if she receives my voice, let her speak through what you call laptop mic.
Ganga, என்னுடைய இதை யூஸ் பண்றீங்களா
Sir?
லேப்பா
Sir, you please hand over your mic to her.
கங்கா எங்க இருக்கிறீங்க
And the same room. I think you people are sitting in the same room.
இல்ல
I see.
she must be வேற ரூம்ல இருக்கிறாங்க எங்க இருக்கிறான்னு நான் தேடி பார்த்தேன் காணல அவங்கள
I see.
Sir, remove the connection. The headphone connection you remove. That.
Yeah.
Don't speak.
What about the Jyotish Lal?
Banish, you are ready, you can present it. Afternoons you can present. Are you ready?
Yes.
Banish?
Bennett?
I'm
If
ready.
you are ready,
present it.
let her
Now,
present.
sir.
Okay, can present.
Let her present
Now.
afternoon session.
அவங்க வந்துட்டாங்க நேரம்
Yeah.
பேசுவாங்க
Nice. Ganga is ready, of course, now.
So is it okay? Can I present now?
Yeah.
Okay.
Yeah, we are able to.
Yeah. Thank you.
Sorry, sir. I had it was set up ready, but unfortunately there was some technical glitch.
The technocrats have got this type of problem. Okay.
Okay, just a moment. I'll share my screen.
Yeah. You can begin now.
Yes, sir. Let me share my. I hope you can see my screen now, sir.
Okay, sorry.
Sorry. Shall I begin, sir?
Yeah.
Okay. So to everybody in the session, I'm sorry about the technical glitch that I had faced. So today I'm just going to speak about recent trends in speech recognition. So what I'm planning to cover in today's session is basically I have worked in speech recognition toolkits, and the latest speech recognition methods, whatever is available. I'll give an introduction to that, and I'll give an intro to the toolkits. First of all, what I'm planning is tell about an introduction about speech recognition. What is speech recognition? How it is actually happening? And what are the current successfully evolved methods which is being used across the world for speech recognition? So first of all, let me start with automatic speech recognition. We call speech recognition as automatic speech recognition. Basically, what it means is I'm speaking something right now. Okay, it is a audio or a voice. In general, it is an audio signal. We call it as an acoustic signal. What happens? This is a audio. This will be converted into a text. Okay, so if I'm going to record through a microphone, say here I've given an example, like my number is 7390274. Okay, so my recording is going to be a sentence telling myself telling some number. Okay, so what is the recording? My number is 7390274. Okay, so this will be recorded as an audio signal. So that is what I've given in the left hand side. It will be recorded as a signal. Okay, and what I expect from the speech recognition system, I call it a system because if I give the signal to it, it will interpret the information in the signal and give me back the corresponding message over here. So the corresponding message here is the text format, corresponding text whatever the sentence that I have spoken here. Okay, so basically the speech recognition system involves converting or mapping an audio signal to the corresponding text information. Okay, so that is the basic idea about speech recognition system. So why we are going for speech recognition system? Basically it is why we started with, all of us are very comfortable with speech as a mode of communication, the human to human communication. If I want to talk to my friend or anybody, basically normal speech conversation is very comfortable rather than like sending a message or so and so. Okay, if I'm going for speech human to machine interaction, where that comes, so today's example we have is something called as Alexa. We have a voice assistant system, okay, which I'm using it in smart homes. Okay, if I'm in my home, if I'm having Alexa, a voice assistant system, I will connect it to most of my devices in my house, which I can control. I can turn on my AC or turn off my most of the electronic equipments in my house. I can connect to the camera to monitor. Okay, so many things. The human and machine interaction is made so much easier through speech recognition. Okay, so I can have a lot of voice control. So one is Alexa, second one is chatbots.
உங்களுக்கு அந்த எலுமிச்சம்பழ சாதம் கொஞ்சம் இருக்கு,
Sir,
கை சாதம் இருக்கு உங்களுக்கு.
okay, the second one
கை
is
சாதம்
chat.
சாப்பிடலாம், நீங்க சாப்பிடுங்க. அப்புறம் ஒரு வழக்கு வைங்க, ரசம் இருக்கு,
Okay.
வடை இருக்கு.
So the one is chatbot. What we mean by chatbot is people would have been familiar with when we are going through some websites, we will have window opening at the bottom where if you want to have some queries, it can be answered over there. Okay, something like chatting, but chatting not with another person, but to a machine. The machine will answer a query. The machine will answer a query. Chatbot. Next is call center help desk. So these are very simple everyday examples that we are having now. Okay, so call center help desk, what happens is when we are first requesting, for example, if I'm having any issues in my mobile phone or in my SIM card, if I'm initially calling to the customer service directly, it will not be connected to the other end to a person. Initially, it will be connected to a system. Okay, so the system will try to solve some queries. If I really want to speak to the customer service person in person, then I'll be redirected. So the advantage over here is most of the tasks can be simplified through a machine. All right, so these are some simple examples, and we have n number of applications using the voice recognition. So first one is voice recognition in smart TVs. We don't have to manually change the channels. We can use voice recognition to give commands to change. For example, if I want to play a movie, just play so and so movie. So that command will be taken in by the mesh, like TV, smart TV. that particular movie will start playing. In bank applications, this is very useful because, and second, one thing is this is very useful. Second thing, we have to ensure that it is highly secure, because I don't have to log in every time using a username and password if I want to make some transactions. I can have a voice recognition application or system which can be a part of my mobile phone as an app. Okay. What I can do is I can just give instructions, like if I want to check my balance, I can say some similar to Alexa. I can have some other app, say some, I'm just giving a random app. Okay, into that app I can ask like, what is my current balance. Okay, so this app will be connected to my bank account through banking. It will retrieve the balance and give back to me as a speech. Okay, your account current balance is so and so. Second, if I want to transfer money to somebody, just I'll say transfer money to my mom. Okay, say what is the command I'm going to speak here is transfer 2000 rupees to my mother or to mom. So what happens here, I will have a record of the account of my mother in over there. Okay, so or the corresponding person I want to transfer, say some Shalini, some person. Okay, the account information will be there, transfer 2000 to Shalini. What happens, that amount will be directly and immediately transferred to that particular person. So this is really advantageous in banking applications. You don't have to go through the hassle of logging to the account, ensuring all the process, taking and spending time. Within a fraction of a second, you can do all the process. So we can have this applications if somebody is driving. So if the person is driving to his office, okay, on the way he can check us all the records, make all the transactions, relaxedly go back to his office. Next, smart home assistants. We have Alexa and a lot of applications we have now. So what is smart home assistance is, we have a small device. This device will have a voice recognition system connected a part of the network in our house. Okay, so through voice, we are going to control the appliances in our network, or control, yes, basically electronic appliances is what as of now we are controlling. Or if you want to, for example, if there are kids at the home, through Alexa, they can communicate with the kids, they can monitor whether what they are doing, and so many things are actually happening. And the next one is voice recognition for translation application. So this is very interesting and very useful today's scenario, because for example, I may not know Korean language, but I'm going to Korea. I might end up in some extremely rural area where English is not available. Okay, so in that case, I might be stuck up without any help. This, we can have a small app, a voice or like a translation app, where if I'm going to speak in English, I want to translate from English to Korean. Okay, so this translation app, what it will do is, I will speak, say something in English, that will translate to Korean, and that sound will be the output of that app. Okay, if I want to ask some help, for example, my help, the request is going to be like, where is the nearest bus stop? In that case, the app will translate the sentence, where is the nearest bus stop, to Korean, and that will be the output, as in it will be given out at the speaker of my mobile phone. Okay, so the other person who's a Korean, who's not familiar with English language, he will understand it, he will reply something in Korean, that will be again translated through this app, and I can listen that back in English. Okay, so this is another application. And another interesting application is earlier medical diagnosis. So this is related to recordings. For example, Alzheimer's disease, we have the one of the symptoms, not diagnosis steps of Alzheimer's disease, is their speech will be affected. The person, an earlier stage of Alzheimer's disease, their speech or the way they speak will be affected. So if we can record and analyze the speech signal of a normal person and a patient having Alzheimer's disease, okay, we can identify significant patterns in this. So this will help in early detection of a particular Alzheimer's disease. And medical diagnosis, apart from that, we can have speech disorders. People who are having the cleft lip and other issues, they will not be able to pronounce properly, they will not be able to speak properly. Okay, so if they want to use some voice recognition applications, that will be very difficult for them. So what we can do is, as a that analysis part, okay, so if they are basically, they won't be able to pronounce vowels properly, a, e, I, o, u, that they will not be able to pronounce properly. So what we can do is, we can have a pre-processing step or pre-end step, a module before the voice recognition system, where the voice from the cleft lip person can be analyzed and mapped to a regular speech, so that they can make use of all these voice recognition systems available. Okay, so AI assistants that can recognize your specific voice. An example could be Siri. The option in Siri is, we can customize Siri application with our own voice. As of now, we know that anybody records something or wants to communicate with Siri, it will respond. But it can be customized for a specific voice also. So only if that particular voice, person having that particular voice is speaking, Siri will respond. Otherwise, it will not respond. Voice identification for security. Why this is? Because our voice or the way we speak actually reveals a lot of information about us. First thing, the dialect we have. Basically, all of us will have a dialect depending upon the region we are from. Okay, a dialect information will always be there in the voice. Based on that, by recording and analyzing the voice of a person, we can find out where the person or which region the person belongs to. Second, the age, gender. So all those things we will get more or less about an information about a person through voice identification. So this can be used. This actually applies for recognition in forensics and criminal identification. And voice identification in security is, I can customize my home, I can ensure security by customizing the application using my voice. Only if my voice is played, the door will open, or I will get access to a particular room or lab. So these are some of the interesting applications available. So one thing, if you notice, a lot of applications involved, for example, in banking applications, smart home assistants, it is not like a very big system or a server or a high computing facility which is going to run somewhere. We bring it to the users as a simple application which can be installed in their phones, or a small device which can they make use of. Okay, so that is where the speech recognition system today is. They bring the application to the user in a very simplified way, which is very helpful for them in their day-to-day life. Okay, some of the fields or areas in which the speech recognition has evolved is, one is multilingual speech recognition. Okay, so in general, we keep the language English as a standard for comparing the recognition performance. So if you see multilingual speech recognition, if we take it in India, okay, so regular speech recognition could be, I can have a recognition system for Tamil. So what the system will do, if I have audio recordings of Tamil speech of say some 5 people, if I give it to the system will translate or transcribe it and give it to me the corresponding text, Tamil text. Okay, so multilingual, and if this is for Tamil recognition system, I can have for Telugu one system, Malayalam one system, Kannada one system, Hindi one system. So in multilingual, what happens is, I don't want to have 5 or 6 different systems. I want to have a single system. Let me take a small example. Like, I want to have it for Hindi, Tamil, and Telugu, 3 languages. Okay, I want to have a single system. If I speak in Tamil, it should be able to recognize. If I speak in Hindi, it should be able to recognize. And if I speak it in Telugu, it should be able to recognize. So how it is possible? It should be trained for different languages and mapped with the corresponding grammar in different languages. Okay. So this, I will talk a little about it when I explain about speech recognition system. Speech to speech conversion is what I just told about voice in translation applications. It converts from English to Korean language, one speech directly to another. This is not a simple process. First, it will convert from English speech to English text. From English text, it will translate into Korean text. From Korean text, it will again generate a Korean speech. So it involves 2 different systems combined, collectively working together. Speech to text text to speech. At one end we have English, another end we have Korean. So this is a very highly useful and interesting application. And recently we have people have focused on telephone speech recognition. Why I'm telling recently is because in 2021, one of the leading conferences, Tier 1 conferences, they released data for telephone speech related to telephone speech to recognize, to build a efficient recognition system. Okay, so why telephone speech, you might think, is because there are a lot of cases where what do you mean by telephone speech? That is the first thing I want to say, because if you like, all of us would have used landline connection as well as mobile connection. So there is an obvious difference in the sound we hear from telephone landline connection and mobile connection. So that is because the speech signal which is being transmitted along the channel, telephone channel, is being attenuated to accommodate that channel capacity. So some information is actually missing in telephone speech compared to the others. Okay, so this is one of the areas where we are focusing on research. Okay, so we know that the challenges in speech. So the challenges in speech actually arrives from the variations in the speech signal, the speech audio which has been recorded. What are the possible variations in the recorded signal? Could be, first one, it has a significant variation due to age of a person. For example, we obviously know that if it is a small kid of 5 years or 10 years, the way they speak is very different from old elderly person. And I'm sorry. And it is different from somebody who's of age, say some 20-25. What is the difference is because the pitch, we call it as pitch or frequency, that information varies. For a kid, the pitch or frequency in range which they speak is very high. Okay, and the elderly person, it will be very low. Okay, this involves something, this is highly related to the speech production mechanism in each individual. Second one, gender. In general, female or women have high pitch or high tone compared to men who have low tone or low pitch, or you can tell it as bass voice. Okay, speaker disorders. I just told about cleft lip. People who have disorders, they will not be able to pronounce certain vowels properly or certain terms properly. And background noise. So background noise is one of the biggest challenge starting in very long back in speech recognition. Why? Because we record an audio. If there is going to be a fan, that sound also will be recorded. So if I'm going to train a model with a proper speech without any noise, and if I'm going to test it with this noise, the machine will not be able to properly recognize this, because this noise, the machine will think that is also a speech sound. Okay, so we have to train that system with noise also. Transmission channel, just now I gave an example of telephonic speech. Emotion is one of the highly challenging area. Why? Because if a person is very angry, the way they speak is very different from the time when they are very happy or when they are very sad. Okay, the tone in which they speak, the rate in which they speak, okay, and the speed in which they speak, the duration. So if they are very angry, they will speak it very fast. If they're very sad, the duration will be little longer. Okay, so the emotion actually affects the speech a lot. So what they do for emotion is they analyze the emotion and find the trend in emotion to map it to the speech recognition system. Speaking rate. I might speak very fastly, someone else might speak very slowly. Okay, so this will affect the recognition system. These are the challenges in speech recognition. So why I've given this is, this will give me the basic insight of what is a recognition system. I told, if you can see at the top, there's a speech signal. This is a mapping from the speech signal to the text. So the text could be, if music could be the food of love, and the corresponding speech signal is this. Okay, how this is mapped? First, audio has to be mapped to the corresponding text. So what is happening? First of all, I'm taking a speech and applying some feature extraction methods. Why feature extraction? Because the signal will be having repetitive information and the signal is very long. Okay, I want to take only the relevant information from the signal. So extracting the relevant information from the signal, I call it as features. We have standard handcrafted features for speech recognition. One is substral features, mel frequency substral coefficients. Okay, that is what is given here, MFCC. Why I'm telling it handcrafted is because speech recognition system imitates how we understand what the other person is speaking to us. Okay, if somebody is telling me, go back to the last page. Okay, so that is a voice. I perceive that sound. I understand what they are telling. That is what speech recognition is actually doing. This perception in human has some significance based on frequency. Okay, so up to 1 kilohertz, the perception is even. After that, it varies logarithmically. So what this handcrafted feature does is, it is going to have filters based on the human perception. Okay, so accordingly, it will filter out the speech information so that the recognition is better. So this is a handcrafted feature for speech processing. Basically, it is used for recognition, speech recognition, speaker recognition, and so on. Then we have acoustic model based on Gaussian. We call it as Gaussian acoustic model. It is based on probability. Okay, so the feature we represent it as O. The Gaussian acoustic model, what it does is, basically, I have, for example, if I take this signal, it is based off a set of sounds. So each sound we can represent it as phoneme. So I don't think I have to explain what is phoneme over here. I'll just give a brief of what is phoneme. It is a basic representation of a sound unit in speech. Okay, so what it is used here is, I'm going to have a representation for each sound unit for the audio in the sentence. Okay, for example, let me take an example for numbers from 0 to 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so in Gaussian model, what I will have a simple, if I'm not going for phoneme, I'm just going for a word model. What I will have is, for 1, I will have a model. For 2, I'll have a model. For 3, I will have a model. Totally 10 models I will have. So what happens, next time when I pass a sound through the model, it will give me the probability values. The model which is giving the highest probability, I will consider the sound belongs to that category. So if, for example, if I'm going to pass the sound for number 5 to all the models, the probability outcome of this model number 5 will be very high compared to the rest. So I will able to know that the sound or the feature which I've passed belongs to the category or word 5 here. Similarly, for phonemes, why we are going for phonemes is, it is more efficient if we define a model for phonemes rather than words. Okay, we can better develop a recognition model. We have, say, some, for example, in English, we have collectively, we have, say, some 39 phonemes. Rather than if we have in my vocabulary, if there is going to be some 5,000 words, I don't have to create model for 5,000 words. All I can do is I can create model for 39 phonemes, which is comparatively easy and more efficient. Okay, then as of now, what I've done, I have a pattern or model for my audio signal. Now, for example, if I have for all this, if you see, if music be the food of love, this is the sentence. Right now, I have a jumble of all the information. All these sound, all these, for example, if we take it as a word level, okay, it is not in order. What I have now is not in order. If I use acoustic model, what I have now is not in order. I know that in the sound, like in the speech signal, these are the words present. How will I know what is the order or sequence of this word? It should have some proper grammatical format. Okay, so it should be in proper order. If should be followed by music, if cannot be followed by food, or off. For example, if and off will not go together. So this grammatical sequence or context is given by all this: phoneme likelihoods, HMM lexicon, n-gram language model, all those things. So this will help me to identify the sequence, possible sequence of words coming one after the other. Okay. So phone likelihoods is, if I take one sound, okay, music. Okay. So if I start with M, mu, okay, it follows by is, then si, music. Okay. So in that case, what is the probability of phones which is following one after the other? Lexicon is nothing but if we have two words, for example, one word is I'm going to department tomorrow. Okay, that two is different from I want two different sets of results. The second two represents number, but first two is different. How we pronounce is same. First one, what I told, I'm going to department tomorrow. Second one, I want two sets of results. Both are pronounced in the same way, but both have two different meanings and both occur in two different contexts. That is given by n-gram language model. Based on the context, it will give me the correct word to be used here. And what is the reason of lexicon? It will identify which is the appropriate word to be used here. Out of 2 and 2, which is the appropriate word. And Vitaby decoder basically will find the correct sequence using all this information. Vitaby decoder will find the correct sequence and give me this sentence from the audio signal. So I hope you got this part. So why I'm explaining all these things is we, first of all, I want to insist on how audio is mapped to the text. Okay, so that is where the major part is. So I have a speech signal. I extract the features. So this we call it a spectrogram. This image here, we call it a spectrogram. It is actually a time frequency representation. Earlier days, in conventional models, we used the speech signal. We extracted features from the speech signal and given to the recognition system. Now, in the current trend, what we do, we take a speech signal, create this representation, spectrogram representation, we pass this as such to the model. Okay, so this I call it as features. So all the information x1 to xt, what happens is this image is being taken frame by frame and given as x1, x2. X1 will be say some, if this is going to be of length, since it is time, this is frequency. So the x-axis is time, this is time, and this is frequency. So in time, I can take some every 10 milliseconds. So every 10 milliseconds will be first small part of the image. Then next part of the image. Frame by frame, it will be taken. And this is acoustic model here. The pronunciation models I told. The language models will give me the final context. Why is the expected output what I want here? Okay, so that is obtained by n-gram models. We have the standard Mel frequency substrate coefficients as well as the spectrogram. Okay, so Mel frequency spectrogram coefficients are extracted over. If I'm saying telling a sentence, it probably will the duration will be probably around 2 or maximum 3 seconds. If it's going to be a short sentence of 5 words or something. Okay, so in that case, let me take this example itself. So this sentence, it is extracted over the speech frames. This will hardly cover 3 to 4 seconds. Okay, so in that case, I'm not going to process entire 4 seconds. What I will do, I will split that into small frames of milliseconds. 20 milliseconds. Entire 4 seconds will be divided into 20 milliseconds overlapping frames. The MFCZ is obtained over there. Spectrogram, this is exactly the spectrogram, this image. The second one, you can see, right? Above features, we have an image here. This is actually the spectrogram. So I have given an idea about speech, the features, HMM. So HMM basically gives me, if I have a feature, what is a probable corresponding phoneme representation of that feature. Okay, so first example, if you see word model for the word the, THE. So in that case, it has basically, probably it has the phonemes DH, first one phone. The second phone will be AX. Okay, so if I take this model, if you can see, it has a starting point and ending point. The first one, it has a starting point and ending point, and there are some, above the arrow marks, you have some numbers, probability value. They represent the probability value. And so if you see, if I train the model, what will happen is, if I'm passing the feature related to the word the to this model, okay, then when it starts, what will happen? At the starting point, you have two possibilities. It can go either to DH or N, but which is having high probability 0.92, it is DH. So it will go to DH. Okay, then it still has two options. One is 0.77, next one is 0.23. 0.77 is high, it is AX, then it ends. So basically what it tells, I have all these phonemes I have all these possible phoneme combinations in my recognition system. Okay, this particular model is for the word the. Okay, so similarly, I can have models for like on, I, need, and so on. So if I have the audio for the word the being passed to all the four models, okay, this will give me the highest probability value compared to the others. For example, it will multiply 0.92 into 0.77 and give me the results. Okay, similarly, the other models will have the corresponding probability values. So this will give me the higher probability. From this model will be chosen during the recognition step as the final one of the final outcomes before the applying the language n-gram language model. So this is a acoustic modeling step. Okay, so this gives you the clear insight of what is happening in HMM. So HMM is hidden Markov model. That is, you can see this circles. If you see at the top, you have a circle that they are called the hidden states. Okay, at left hand side of each circle, we have a curve. We call it as Gaussian distribution curve. Basically, the probability value, whatever we have, is obtained from this Gaussian distribution. So what is happening here, this observation sequence at the bottom is going to be my features. I told you we have a spectrogram. We will split that spectrogram into small frames. So each strip over here will represent one of the frames in my speech spectrogram. Okay, so this will be given to the states or the acoustic models in my recognition system. The models will generate a give me the probability value. Based on that, I can identify the possible state. What could be the state? So here the states are DH and AX. These are the states. So this will be combined finally into a word. Basically, this is a phoneme sequence, DH and AX. Using lexicon, I will get the word the from this model. If I apply the lexicon over here, first I will get the phoneme sequence through this model. Phoneme sequence is DH and AX. And if I apply the lexical information, I will get the word the. Okay, now I have a set of words here. After that, I'll apply the n-gram model to get the sequence of words, finally arrive at the sentence. So before moving on, I'll just pause for a second. So I hope you understand what is happening in speech recognition. So if you have any doubts or anything, you can please feel to ask me. Otherwise, I'll continue. So is there any?
Highlighted some of the issues and the present state of affairs of speech recognition. Of
Yes,
course,
sir.
she has given various applications. Similarly, what are the challenges people face while we are implementing the speech recognition concept? And
Sir,
she has also
may I
taken.
interrupt? I'm
Hello?
sorry.
She
May
has
I interrupt?
Yeah.
Actually, sir, I just paused in between so that if there is anything I can answer, then I'll continue.
I see. Yeah, please, you can proceed further.
Okay.
Yeah.
Thank you, sir.
Okay.
So I believe that there are no queries.
Everything is reachable. People are listening to that. And you please
Okay,
go
sir.
ahead.
Okay, sir. Thank you. So I want to understand how efficient my model is. So how will I know whatever audio I am giving to the system, it is giving me the correct sequence of like correct sentence. For example, if I'm going to give 1,000 audio files to the system, I'll get corresponding 1,000 sentences. So in that case, how will I know it is how efficient our system is? So I have a performance matrix called word error rate. We have phoneme error rate also. Basically, what this error rate represents is, I have a sentence. Okay, the sentence could be today is Wednesday. 3 letters. First one is first letter. 3 words. First word is today. Second word is. Third word is Wednesday. Okay, so n is going to be the total number of words 3. I, D, and S are insertion, deletion, and substitution. Insertion is instead of 3 words in the recognition, I'll have more than 4 words. Okay, it is actually the 4th word is actually wrong. Deletion is one of the expected word is missing. For example, the second word is missing. I get the response only as today and Wednesday. Is this missing? Third one is substitution. Instead of is, I will have something as was, which is not correct. So these are the 3 possible error that can happen in recognition. Okay, so we can have it as word error rate if I'm going to consider my recognition output as words. It can be phoneme error rate if my recognition output is phonemes. Depending upon that, it will be varying. Okay, so these are the toolkits. We have HTK as hidden Markov model and Kaldi. So HTK completely works on hidden Markov model, which I explained just now. So we have a specific model for grammatical or linguistic information, which is nothing but the n-gram lexical information. We have separate model for acoustic signals to model the acoustic signal acoustic model that is using Gaussian mixture model like GMM, Gaussian mixture model, and we have features. Each step is separately as a model. In Kaldi also, the advantage of Kaldi is it supports the deep learning. The current whatever we have deep neural networks, it is supporting that. Okay, so whatever I spoke till now is conventional method, which is being there for some time. Now we have moved on to deep learning. All these separate models has been converged. If you see the first one is conventional method, we have separate models for each step. Second one is hybrid model. Hybrid model, one of the module is replaced using deep learning method. Third one is end-to-end ASR. That is what we have currently. What end-to-end ASR does is, I give a speech signal. There is only one system, no separate modules. It gives me a text out. A single system, a single network. Okay, so this is a basic idea about deep neural network. Okay, the circle represents neurons. I have an input layer where my speech signal will be passed. Okay, so if my speech signal is going to be of length, I'm going to take a part of speech. It could be say of length 160. Okay, it will be passed over here, and I have hidden layers where all the learning part is going. All the models will be modeling part will be done here, and finally I have the output layer where I will get the corresponding word. Okay, so I'll pass an audio at the input layer, I'll get a text at the output layer. All the feature extraction, acoustic modeling, language modeling, everything will take place within the hidden layers. So as of now, we have different networks, deep neural networks, currently standard methods, which we are using based on this model. Okay, so some of the, I'm sorry, this is not E at E, it is actually E to E, end-to-end system. E to E, the number 2 and E. So I've chosen very few methods which gave really good results and which we could call as benchmark in speech recognition. We have lots of methods. Since we can say some 20, starting of 2010 and 2010, 11, they became as a standard. Deep neural network has become a very standard in speech recognition system. These are the benchmark methods available, which kept on evolving and improving the recognition performance in different aspects of speech recognition. We had different challenges like emotion, noise, and speaking rate. All those challenges, we can have benchmark results using these methods. I'll give a brief overview of what these things are. Okay, if you take the convolution neural network, we are going to pass, in general in speech, instead of passing an audio signal, passing the spectrogram, the 2D image to the network was giving good results. Why? Because if you see here, the blue color, the background blue color actually represents no information. The yellow color and represents the information. The dark red color represents basically the pattern in the signal. Okay, so the yellow and dark red variations are actually representing the speech. If you see the vowel and the variations in the it will represent the speech variations. The yellow basically will give you the unvoiced part, or the aspirations. All those things will be represented using the yellow color. So what happens in convolution neural networks is, I have a spectrogram here. Okay, it is actually an image. I take a small part. You can see the black box here, right? I'm going to take a small part of that image, and I'm going to convolve the mathematical convolution over a filter. Okay, so what it is going to do is, it will capture the information in this particular small frame. This is my convolution layers. You can see the violet color boxes here. This is my convolution layer. So this information will be captured over here. So there are two steps here. First one, filtering and max pooling. So each step I will have, for example, within this box, I will have, if I convolve with a filter, I'll get a set of values. Max pooling is going to pick out the maximum value out of this. Okay, so what I understand, like what I will capture is, only the relevant information within this box will be captured at the outcome of this convolution layer. Okay, so this is very efficient in speech recognition. After that, I have something called as fully connected layers. That's nothing but each neuron will be connected to every other neuron in the next layer. Okay, then finally I have a softmax layer. This is going to give me the possible sequence of the expected word outcomes. Okay, so you can see there is an obvious difference between the HMM model we have seen previously and over here. We directly take an audio, and using the neural network, deep neural network models, we make the model, we train the model using several samples of audio. This is not just going to be one audio. I'm going to have, for example, I will have, say, several copies of the same audio, repetitions of the same audio. For example, if it is going to be a word, speech will be recorded, say, some 1,000 times. Okay, all the 1,000 will be given it for training, so that the network is efficiently built. Okay, then finally, if I take in a new audio of the word speech, okay, it will be able to identify the corresponding sentence and give me at the output the corresponding word speech. Okay, so this is convolution neural network. Basically, what happens, in each layer we have something called as weights and bias depending upon the equation. Okay, so accordingly it will alter depending upon the information. The weight and bias will keep on varying to efficiently learn this information. Okay, so the convolution network is about this. It is going to have filters which will convolve with the input. Okay, and based on the max pooling, we will get the information and pass it to the next layer. Okay, so the second one is encoder decoder network. Encoder, what is this? I have a feature. This feature will be converted into a fixed dimensional representation called a fixed dimensional vector HT. HT is a representation. So the feature vector is encoded into HT. We have very good working neural networks, deep neural network methods like LSTM, long short-term memory, RNN, recurrent neural networks. Using these methods, we can create this vector. So why this is happening is because my audio is going to be a continuous signal. The text I expected of this audio is just going to be 4 or 5 words. The matching, it doesn't exactly match. Some words will take more interval duration, some words will take less duration. Okay, so the matching, there is no proper matching between these two. That is why we are going for a fixed dimension here. Decoder, what it does, each step out of the previous step, depending upon the previous step, it will predict what is the probable word. Okay, if you see here, x1, x2, x3 are going to be my feature vectors, in like input features, the MFCC features or spectrogram, whatever we have, that we will pass it to the encoder. So this is the encoder part. You have RNN at each step. This encoder will give me a vector. Okay, so this vector is passed to the decoder. The decoder will, based on the first value, it will give me the first possible speech text output. Okay, so y1, y2 are my expected text outputs. So the decoding paths. Okay, next one is attention based model. This is one of the models which gave very good results for speech recognition. So it started, I believe it started with NLP. Now it came into speech recognition. Okay, so the difference between attention based models and this one here is attention based models, we have initially, we have, for example, if it is going to be a word cancel, it has like letters CANCEL. Okay, so in that case, in this word cancel, the starting letter or the first predicted letter is C. Okay, I have an initial context over here. Okay, so the attention based model is based on some context. It will go and predict the next. I have a set of characters in my system, like in my recognition system. Out of all that, based on the given context, what is the next possible? So this is attention. Okay, so you can see initially C was recognized. Now based on this, based on this, I'm going to choose the next letter A. Okay, and so on. Finally, this will repeat. Then next N will be chosen, C will be chosen, E and L, cancel. Okay, so specifically, I'm not going to decode with all possible, like decode based on using all possible scenarios. I'm going to fix a constant context initially. Only as the context as a subset, I'm going to go for decoding. Okay, so this is one of the well-established methods that came in around 2015, and it was very popular in 2018 and 19. It went to peak at that time. Listen, attend, and spell. Listen is where your acoustic component happens. Attend and spell is where your decoding takes place. So you can see here in the first block in acoustic model, at the bottom we have a set of neurons. At the level above, the number is reduced. At the level above, the number is reduced. What is happening here is the time resolution. Okay, time resolution keeps on decreasing at each level. Okay, here initially we start with very fine small intervals, then we keep on reducing that, we go up. So what is happening, finally we will end up with one possible acoustic model outcome for a given audio. This is given to the decoder. So it is kind of what is happening here. I have a context. Okay, based on that context, I'm going to find the next possible. Similarly, I have an acoustic signal. Okay, I am going to improvise that acoustic model by fine-tuning based on the time resolution and give out the outcome of an acoustic model here. This outcome is given to the decoder to finally give me the possible sequence of the outcome. Okay, and the another one which gave really good results for speech recognition is connectionist temporal classification, which we call CTC. Why it is this? If you take, I told you we are going to split the signal, the spectrogram into small frames. If you see at the bottom image, there is a division. X1 is 1 frame, X2 is 1 frame, X3 is 1 frame, X4 is 1 frame. What will happen sometimes is the same information will be carried over in multiple frames, because it is like frame will be very small. Okay, so that information will be covered only in multiple frames. If it is going to be uh, word do good, okay, so the good might be covered in say some 5 to 10 frames. Okay, so the sound O will be covered at least in 3 or 4 frames. That is, it will be repeated in 3 or 4 frames. Okay, so what happens here is, if you see the example here, the second one, cat, what I expect out of that sequence is just a word cat with 3 letters. Okay, but what will be probably recognized initially is the first frame will give me C. It is not single C, double C. Then there is that within the embeddings we have B. Either we have this representation, or we will have hyphen to represent like interval between the successive frames. Okay, so within the brackets what we have, this B is actually the interval between the frames. Then I have A. It is not just one A, double A. Then I have T. This is one possible outcome of the model. The second possible outcome is a C, 2 successive intervals, A, another interval, B, another interval. So these, if you see, these are all the possible outcomes of the acoustic model. Now I have to find a proper word for this. So there are 2 things followed here. One is, if you take the first example, CC, first example, first part, double C. What happens is, within a frame, if something is repeating, I'm going to keep only one. So here I'm going to keep only C. The second C I'm going to neglect. Okay, so I'm going to, here if you take C will be retained, there is a pause. Second A will be retained, there is a pause. Second T will be retained, there is a pause. This is one step. Second step, I'm going to remove all the intervals and concatenate whatever text I got. Okay, so the intervals between C, A and T will be removed. Finally I'll get the word cat. So if you take all the other possibilities, this is repeated. Okay, so the advantage is, if I'm going to what is the advantage here could be, here cat we have 3 unique letters. Okay, in case of good, G double OOD, O is repeating twice. Okay, so in that case I might have say multiple, like 5 or 6 frames I'll have O repeating. Okay, I should get the proper word. What will happen, both O's will be recognized because there is an interval between the frames. Okay, so all the values apart from the intervals will be written as such. Within a single frame I'm going to remove the repetitions. So this model really improved the recognition system. This model was used as part of the recognition system, probably at the end, to improve the recognition performance. Okay, so these are my references. So what I was planning was, I wanted to give you an insight of the basic or the state of the art benchmark methods. We have a lot of benchmark methods as of now, but all of this is one way or other related to the methods I've spoken right now. So I want to give an insight. So with that, I came to the end of my presentation. So I'll be happy to answer any queries. Thank you, sir.
Speech technology, and she has touched upon some examples also, giving the cat as an example, how it is mapped in computer language. Various methods he has presented. The participants can participate by raising questions if you want to have any clarification over the issues she has narrated. She has touched upon various aspects of the present day situation. What are the things followed in speech recognitions and the challenges. He has also said that. Better you can raise some questions. Friends, any question? Professor Umaraj, Professor Agilan, Professor Agilan, Professor Panis Narayanapillai is there, and even Professor Rajendran can also question.
Sir,
Yeah.
let me speak
Yeah.
2-3 points. There is a good presentation about good hidden Markov model and the probability things and the n-gram model and how to make the language model, everything. It's a good presentation. But have you done anything related with the Tamil or Malayalam or any other language? Because you are all the examples are in the English word.
Yes, sir. Actually, I am currently working for Tamil. So basically, I worked in the toolkits Kaldi I mentioned. No, I worked for English mainly. So currently, I am working for Tamil in these toolkits. So I didn't include any results because I want to give an insight of what is available. So that is why I didn't include any results related to that. Tamil, I'm working on it now, sir.
Okay, good. So simply saying, what is the role of phonetician or phonetician in your things? Phonetician means.
Yes. Main role could be in the language model, sir. Because, for example, if you take Tamil, it's morphologically rich, and the dialect is too much. There is too much variations in the dialect. Okay. So that is a very big challenge in Tamil recognition system, speech recognition system. So the performance depends upon the I've mentioned, if you remember, the lexicons and the n-gram model. So this is actually a black box to a speech, the person who is developing a speech recognition system. This is actually coming from a linguist. The lexicon basically, it gives the phonetic sequence of a particular word. N-gram is going to, if it is going to be bigram model, it is 2. Okay, so the bigram model, if I'm taking, it will give me from the data, it will give me the sequence of 2 words. What are the possible sequence of 2 words? For example, if the first word is today, the next possibility is I cannot have Monday. Today, Monday, I cannot have. Today and is, there is a possibility. So this sequence, today is, good morning, good afternoon. All these sequence will be part of the n-gram model. So this is very important. What happens in the initial phase is I identify the set of words corresponding to an audio. But the grammatical context only comes from the linguistic information. That is going to be the lexicon and n-gram model. So that is where the CNC came into picture. Connection is temporal classification. The last thing I told you, that is one of the advanced deep neural network method where the from the available sequence, I'll be able to correctly identify the required word or sentence.
Okay, but good things. Unigram, bigram, and trigram model. N-gram model is good. And suppose English is good. I am going to the market. If the sentence is I am, will get. I am going to market. Will get. So that is bigram. I am. If I take to consider as a bigram, I am maybe ing form will come. But in Tamil, if I say that நான் தமிழ் படிக்கிறேன். So it is better to use the trigram model. The trigram model நான் தமிழ் படிக்கிறேன். Because non-Tamil knowledge won't get that one. படிக்கிறேன், how to get that one. So the Phoenix model and the Stokes model, usually they use the trigram model. A unigram, bigram also good. But the trigram model is the better option.
Okay, sir. So in bigram, this is also available, sir. நான் படிக்கிறேன், நான் படிக்க போகிறேன். So நான் படிக்கிறேன், நான் படிக்க போகிறேன். So நான் படிக்க போகிறேன். 3 words are there, இல்லைங்களா, sir? So in that case, நான் படிக்க will be one sequence. படிக்க போகிறேன் will be second sequence. Yes, obviously, as sir told, trigram model will have better results. But in bigram, we have both the sequences also available.
Okay, நான் படிக்க போகிறேன். நான் படிக்க போகிறேன். I'm not that much expert on Tamil, but so படிக்கிறேன் is this unigram, bigram, trigram.
Yeah, the morphological structure.
Better option that is implemented in Phoenix. and the Spinix model for the automatic speech recognition, the Carnegie Mellon University. That's the things. Okay.
That's fine.
Yes, sir.
Okay. Any other question? Yeah. Of course, it's quite natural that we cannot apply all the methods applied for English language and globally. Region specific features have to be accommodated when we want to, what do you call, go for the spoken language analysis. Of course, according to the need, we could modify the methods. Even the Python model can be modified according to the need of our language. Based on the linguistic corpus we develop,
Yes, sir.
we could modify
Yes,
it.
sir.
Okay, so
Yes, sir.
instead of going for indigenous methodology, rather we could borrow a method from other language and we could adapt according to our need. And okay, so such a way you could compromise. Okay. Okay, anyhow, since there is no question at all, I sincerely thank for your nice presentation. And of course, on time you have completed your lecture. Somehow it is very illuminating and it gives a lot of new ideas and it presents the present day situation of the speech recognition being followed in the technical aspect. Much. Thank you very much.
Thank you, sir.
Ms.
Thank you for
Ganga
this
Gauri.
opportunity.
And, thank you.
Thank you all.
Thank you. So, my friends, the session is over since it is 1:10. Okay, let us meet by 2 o'clock. Thank you very much. Thank you for your active participation, and senior professors have participated in deliberation. Thank you very much. Thank you very much.
Thank you. Thank you very much.
Hello. 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 Check. Hello.
Let's begin.
What?
Good afternoon to everyone present here. Now, the sixth session, rather the final session begins now, in which Dr. N. Banish is to deliver lecture on the topic called the relevance of phonetics and acoustic phonetics on speech technology applications. This will be a quite interesting lecture, and of course, listen carefully, and I request all the participants to participate in the discussion to be held after the lecture is over. So, Professor Banis will be talking for more than 1 hour, and of course, up to 4 o'clock, the session will be lingering, and your cooperation is solicited. Kindly be present and participate in the deliberation actively. Okay? With this word, I request Dr. Banish to deliver his lecture.
Yes, sir. I will start. I first of all to upload my PPT. Just wait. Sir, can you see my PPT?
It was visible, now it is not visible. Okay.
Okay. Just a minute.
No, only the screen is there. Yeah, now it is there. Yeah, now it is.
Yes, no, sir. This is the PPT. I will put it in. Yes, sir. Yes.
Yeah, it is there. Yes. Relevance of phonetics and acoustic phonetics.
Sorry, sir. 1 minute. Okay. Vanakkam, sir. Respected scholars, respected chairperson, respected dignitaries in the dais, and my dear student and colleagues. First of all, I would extend my sincere gratitude to Professor Thanjavur Rajendran sir, who gave me the opportunity to deliver a lecture on this topic. So, I am not that much of expert on Tamil, but I will make a simple statement. Tamil en உயிர், தமிழ் மொழியும் என் உயிர், தமிழ் மொழியிலும் என் உயிர். Why I made this statement that I will make the comment on this topic at the end of the lecture. Sir, everything is okay? Am I audible and everything, video and everything?
Yes.
Sir, I could not get the time to prepare some more PPT. I have some maybe 11 or 12 PPTs with me. And first of all, I start with a famous person. You can see that this book, A Descriptive Analysis of a Dialect of Tamil by late Professor V.I. Subramaniam. Yes, that some of the statement is in that that book. That means Professor did his PhD at Indiana University, USA. After that, he published this book at International School of Dravidian Linguistics, 2003. This book is very valuable. Very valuable means Professor has that much of vision, and he explained with the vowel formant and the glide formation and everything. So, fortunately, I got an opportunity to work with the Professor V.I. Subramaniam, and most of the people in the dais also got an opportunity to work with the Professor V.I. Subramaniam. So, several subjects discussed here. Several subjects, and most of them are, not most of, all of them are informative, related with the phonetics, acoustic phonetics, machine learning, and CNN convolutional neural network, and spectrogram analysis, automatic speech recognition, and speech-to-speech translation, and several topics. So I am not going to explain all the concept behind this, especially acoustic modeling, frequency, amplitude, or fundamental frequency, or several algorithm, CNN or RNN or something. I am not going to explain anything. So my topic is, I mentioned here that the relevance of phonetics and acoustic phonetics on speech application. This is very important topic. Means what I say, language comes first, then only any technology, even computational algorithm or computer or the mathematical things. So some of the statistical information, statistical, mathematical, and mathematical modulation of this topic into machine, especially computer or some other things. So the phonetics and acoustic phonetics had or have the importance before the invention of computer or any other technology. So in the book Descriptive Analysis of Dialect of Tamil by late Professor V. A. Subramaniam, ISTL, he mentioned about idiolect, dialect, language, and speech. This is very important. Idiolect means, all of you are aware about idiolect means individual speech, my speech, and dialect means a speech community. Some of the people have included in that, and the dialect and the speech community. Above the peripheral level, we can make the concept of language and the speech also. So I mentioned that several technology. Now everything is in fingertips. I mentioned use of speech technology and predictive artificial intelligence. Predictive artificial intelligence, various useful technology for differently abled persons. First, I will make a statement on useful of technology. We can make I can make a statement on this particular subject, speech technology. No need to go to the machine translation or text analytics, video analytics, and several technology. The usefulness of speech technology is that the technology we are using for Google Meet, or the usefulness of this technology for differently abled person. Suppose one person is differently abled. I cannot say that deaf, but differently abled person, if deaf or some language what impairment, what it is say, the language impairment. There are several Parkinson's or something, that dyslexia, and several techniques. These several techniques, especially in speech technology, can be useful for the differently abled person. That is right. We can also proud that the CEO of Google is a Tamil person, and Pichai, but is a Tamil person. We can proud of that. There are several people in Microsoft also on Indian. And Indian companies also. So many people are leading. And we are expert on the software technology and software field also. So that is a usefulness of technology. I made a statement that predative artificial intelligence. தமிழ் என்ன சொல்லுமா? நான் தமிழ் பேசுறியா வழக்கம் இல்லை. தமிழ் என்ன பேசுற தப்பு பண்ணுங்கோ மன்னிச்சுனுங்க. predative artificial എന്ന് சொல்லியா இரையை தேடும், இரையை கிட்டும், இரையை வேட்டையாடும். Ira means prey. We means some of the common people. That means the artificial intelligence nowadays is used for it to get the prey. To get the prey means everything is that the technology is that much because they want to sustain. Because if there is no prey, no one can. So the technological giant who I work in Microsoft also. I have a gratitude to Microsoft and Google and everything, Yahoo or some Amazon or several. But the backend, actually, if they are to get the prey, and they are hunting, and for the business purpose they are using. This is the real scenario. That I mentioned the statement that the predative artificial intelligence. Do you know the latest technology is the Neuralink? It's a famous person who is a name I could not recall the name. He made the Neuralink. Neuralink is being used in USA. It is being used in USA. That means the authority of USA and some of the health or something, they did not allow still now, but they are using the Neuralink. Means they can, the system can also identify our movement, our behavior, our everything, and our mind and even brain also they can study with these technological things. So plus point is they mentioned that it can be used for the differently abled person or paralysis, brain paralysis person. Some Stephen Hawking also, the physicist, he also used the text-to-speech system for the communication. One aspect that's good, but I don't know about that. If it goes to above and above, whether it will against the human being, whether it will against the humanity or human being, that is my concern. I hope that it won't happen like that. So this is the thing. And the next talk is I will come to the technology. Intonation and speaker identification. As you know that intonation, one of the important suprasegmental features, is considered as one among the complex speech properties, and its theoretical and scientific study got immense popularity in technological field. Intonation is defined as the speech melody occurred in the speech of a speaker due to the pitch fluctuation. Pitch fluctuation is closely related to the frequency variation. Yes, because intonation, as you know that, intonation is a suprasegmental features. Intonation, rate of speech, rhythm, and it is very difficult to understand the rhythmic pattern or the intonation pattern, and the implementation of this intonation features into the system is not an easy. I am telling you that somebody can do the research and somebody will do that intonation pattern and they will make. But I said, as you, the machine is always machine, and the human is always human, and the language and dialect and idiolect, it is changing in a fraction of a second. It is changing that the language, dialect, and idiolect is changing the fraction of a second. So I will. So what to say? So it is better. Everyone, so many people are discussing about these different theory, technique, and everything. This CNN convolutional model, hidden Markov model. I am little make some happiness to the people that suppose if you see that your famous actor, the Tamil actor, he will speak very Vadiveru. He speaks or make very witty person, and he makes a particular tone to make the sentence or in a what to say happy environment. So what his I am just imitating. I am not that much of என்னடா இதற்கு சொல்லி வச்சுறேன் எனக்கு ஒண்ணுமே தெரியாது. So it has a particular pattern. It has a tone. So at that tone, if you no need to see his face, but if you hear that voice, and you will get happy. So it has a particular tone is there. In my speech is also, if you record and analyze, or if you analyze that, my speech has a particular features. And to come to the point in another similar Kamal Hassan, but I am just simply Kamal Hassan, what to say in the Shavadaram film or something, but கடவுள் இருக்கு நல்லது, கடவுள் இல்லை அதுவும் நல்லது. That is one type of speech. And what to say, Rajinikanth, particular style. Basha ஒரு தடவை சொன்னா 100 தடவை சொன்ன மாதிரி. So some politician also, they were Kalanchar or some Jayalalitha, so many people, they have one particular type of speech, and they have a particular type of tone, and they have a particular type of intonation. That is come to the point that the intonation, what I say, the intonation is the pitch fluctuation, and it is basically related if you analyze with the spectrum or spectrogram or some tools like Audacity and Prath or what to say, several open source tools are available. You can record the speech, your own speech, and you can analyze and you can identify the intonation features. And that is a concept. Then I mentioned here that the speaker identification, that is very important subject. I told you that the particular tone, I am not going through the huge data and the data processing and annotation and in between the the usage of the algorithm, different algorithm. I mentioned a CNN or neural network or something to extract the spectral properties and get the speaker identification. Okay, that's okay. The huge data is there. I mentioned also very important things is here. Nowadays, data is important. Even algorithm is also, algorithm is several algorithms are available in website. And ChatGPT, someone mentioned that ChatGPT, if you type in the ChatGPT section, you will get the code, you will get the GUI or any application. If you type the pipe install Python pipe install Spinix or pipe install Festoworks or Festivik, it can get, and within time you can get the output, even for speaker speech recognition, speaker identification or even the speech-to-speech translation. Somehow difficulties are there. As I told you, the technology is that much. So, Indonesian, I hope that you got a brief idea about this subject. I will come to the speaker identification later. And my assumption, my hypothesis is that if we study the pattern of tone and intonation, that is enough to identify the speaker identification. That is enough. Intonation with the tone and particular rhythmic pattern, the speech pattern. If you get, that is enough to understand the speaker. So there are several methods related with the pitch extraction and maybe MFC, signal frequency, capsule coefficient, and several things are available and algorithms are available. But my suggestion to the student and computer science that you make the algorithm. And when the so many scholars explained in the inaugural section that use open source and open source software and make your own algorithm, and that will be useful for that. So my hypothesis of the study, I told you that I didn't get the time to prepare the PPT and everything. That is the things I made. Some of the things my study, my research topic is on the intonation, and some of the things I mentioned here, and the hypothesis I mentioned, sentence level analysis of intonation, intonational phonology of Malayalam with reference to Malayalam syllable rules, semantics of different intonation pattern, statistical analysis of speech parameters. So, sentence level analysis of intonation. Suppose if you record the speech in some any software with a different 22 kilohertz for test speech or 16 kilohertz or something, and simple some tool if you can get, and you can make the analysis, sentence level analysis of intonation. But whatever the thing is that you have to hear very properly, you have to analyze the data, and you have to make that statement. Then intonational phonology of Malayalam with reference to Malayalam syllable. Am I audible? Sir, somebody can respond.
Yeah. You're audible.
Okay, thanks.
You are very much audible, Dr. Banish.
Okay, thank you, sir. So, this is sentence level analysis of intonation and the intonational phonology of Malayalam with reference to Malayalam syllable rules. My study, because it can possible to apply other language also, Dravidian language, Tamil, Malayalam, and this Telugu or Sanskrit or whatever language that is possible. So intonational phonology of Malayalam with reference to Malayalam syllable rule, semantics of different intonation pattern. You see that semantics of different intonation pattern. If I change a particular rhythm or if I change a particular tone, the meaning will change. The sentence meaning will change. It will become the emotive way. Sometimes it may anger, sometimes it may happiness, sometimes it may sad, and different things. The pattern, if you change the intonation pattern, the tone, if you change, the meaning will change. Then the statistical analysis of speech parameter. Statistical analysis means everything is there. That probability there, conditional probability there, and RNN, CNN, or different things are there. But you see, one important thing is that system can understand only 0 and 1. Still, 0 and computer or lab, some computer can understand only 0 and 1. And again, the probability come and 0 to 0.1, 0.2, 0.9. whatever several technology came. I told you that the neural network, deep learning neural network, but all the different mathematical model they implemented. But at last, the calculation will be 0.1, 0.2, and 0.3 up to 10. So that is the things. So if you make the analysis of the speech data and to analyze and to get the statistical measurable data, we can identify this intonation pattern in semantic level, and the intonational phonology, that is a little higher concept. Intonational phonology means you can see that this diagram. This diagram, you see that one is utterance, the second one is the intonation phrase, the third is food, and the rest of the things, nucleus, heavy vowel, and that's one set, and rim, nucleus, and this type of that is classification. Classification means this is the intonation phonology. Intonation is too much difficult to study about this. Then you see what is the theory of this intonation phonology. This is the analysis. This is the analysis I made. The sentences I have the Malayalam enikku aa katha ishtamai. Tamil enna sollum enikku aa kathai ishtamai. Kathai enikku aa kathai ishtamai. Difference is not that much more. But if I say that enikku aa kathai ishtamai, that means I like that story. So various meanings I can make. Enikku aa katha ishtamai. That means I like that story, but I don't like this story. So this type of meaning, this type of inference, this type of phonological inference, and this type of intonational inference and intonational knowledge can be useful for the speech applications, especially speaker identification. So I mentioned here the phonology of Malayalam intonation. Intonational phonology of Malayalam with reference to the acoustic analysis of speech data. The heavy and light syllable in Malayalam. The given sentence has 3 intonational phrases. I mentioned here that this type of thing, sounds and rim, nucleus. This intonational phonology, the phonological concept, the phonological framework is very good for the phonetician. I am talking about. I am phonetician. If you won't get the data or speech data, a good phonetician, a trained phonetician, can easily extract the information from this phonological inference or intonational phonological inference. That I mentioned here. Same thing that Eniki Akada Ishtamai, I date you case. Okay, I like that story. That is, you see that in this phase, I don't know, because the screen is very small. That so you can see that I mentioned, I marked this high and low, extra high, low, high, low, high, low, and falling, the rise, falling, and this marking, this you see that this marking, the marking of these features, low, high, extra high, these features will be useful for the speaker identification, or speaker identification through the computational technology, or the speaker identification through the manual analysis, means the phonetician's analysis. That will be useful. So you can see that one important thing, the declination of fundamental frequency below shows waveform, auto pitch, raw pitch, and the spectrogram of the sentence Ningal Vannan is a Malayalam word, please come. Tamil Ningal something, some little difference is that there is no drastic difference between Tamil and Malayalam. You can see that. So the very important thing is that it's a honorific word. It's a respectable, sorry. It's a respectable words. So what you see that it is a particular pattern is there. I marked with this one. I marked this one, and you can see that the two lines and blue lines are marked like this way: high, high, which is high, low, high, and the slowly falling that. So suppose if we make a respectable sentence, suppose if we communicate with someone, if we speak to someone, and we usually make a polite word. If in this polite context, this polite sentence will make a slow declination. So declination is there. So slowly. So, but suppose in some unhonorific sentence, or suppose somebody is angry or something like that, the pitch will raise, and the fundamental frequency, the voice will raise up to high. Suppose that you get out from this room. So something, if you say that some that is the pattern is different for the honorific words and the non-honorific words. That pattern is very important. So again, I come to the conclusion that the speaker identification, if you get a person's speech, the machine, okay, I can, in the machine level, if you get that speech, and to analyze that speech, you can see that this variation. This is very important. The declination of fundamental frequency declination, the pitch declination. Actually, what happened? The tone usually come down, and the way of speech, and that is usually come down. In contrast with the other sentence, or the angry or some sad or something, that will be different. So then speaker identification. Sometimes I also feel that sometimes why to do this speaker identification, especially for criminal investigation or something like that. Why to do this speaker identification? But on aspect positive point, I am telling that you should not make a criminal. If you make an innocent person to be a criminal, that is a highly dangerous thing. On the contrary, the criminal should be punished. So this speaker identification technique can be used for the criminal investigation and the court proceedings and several things. So you see that so many people mention about Apple Siri and Amazon Alexa and Google Assistant and everything. And nowadays, most of the technology is switch over to speech recognition, speaker identification, several things. Why, especially in India, it's most of the people in India prefer to communicate through speech than writing due to the high rate of illiteracy. That is a problem. The literacy rate is more in India. Somebody cannot write, or somebody cannot type in that mobile, or somebody cannot somebody cannot read. The illiteracy is more in India. So at the same time, the population is more in India, the second largest populated country in the world. India. First is China. Probably India will also overcome China. That is most of the technological giant speculated in India to do the research on speech technology and speech translation, speaker identification and everything. So speaker identification, as I mentioned here, that Somebody is speaking through computer, mobile, different channels such as wireless, visual media. These several techniques. In wireless also you can see some media and well, the telephone speech and several speech, even noisy speech and several things are related with the speaker identification system. So every technology has plus point and minus point. That is right. So we can take, or we can go ahead with the positive point, and the positive point of the speaker identification. Somebody misused the speaker identification techniques, and that is not in our hand. So this is some inference. Inference means, now I told you everything is available. I read the newspaper in Bangalore also, in computer science and everything. Their domain, they banned Chat GPT and but some of the things are available. GitHub copy and everything is there. Thing is that if the student doesn't know anything about that one, and he makes some of the things in Chat GPT and make that this is my algorithm and I made this like this way, then everything will be collapse. The good student cannot get the chance to come the education stream. That is the problem. That is one aspect is there. This is more problematic in the other domain. Computer scientists and professors or expert can understand the positive point and negative point of this technology. But in other domain, especially in some geology or even in some of the linguistics or some of the different domain, physics, or if we apply these things, if we use these open source technology tools and technology and to misuse that one, that will create a big problem, and it will create a big problem in the education section. So this is some analysis. You can see that one is x-axis is time in seconds and y-axis in frequency hertz. But this is Python. I mentioned it's an open source programming language. It's a good things. And I have to mention one point also here. The Python Guido 1, but Guido 1 mentioned, he's Guido 1. He mentioned that one statement. You point out, I don't have life. That is why I invented Python. Guido 1 Rossum, the founder of Python. But he invented the Python language. I don't have life. That is why I invented Python. Good. It's a good statement. So I come to the point that here I mentioned only the phoneme that. Phoneme are 1, 2, 3. I mentioned about some numerical explanation. 1, 2, 3, 4, and Ardha, Ra, 3. So this is everything is concerned with the phoneme phoneme explanation, phoneme things. But why I made this phoneme statement that the syllable. Everyone knows that the syllable is most prominent, and syllable is the good analysis technique for the Indian language. So from this phoneme analysis, you can get the syllable formation also. That is not. So you see this x-axis. This is the speech recognition data of a female one. One female data, I analyze and go to the inference of this one. Y-axis is the frequency in hertz, x-axis in time in seconds. That. So you see that when the combination, the different color used for different phoneme. So this is the graph is speculated on a particular space, 200 to 250 to this frequency hertz. In between this the frequency hertz. So as usual, that the female voice will be above 250, near about 300 hertz. That will go that. So this is a simple inference. It's a simple inference from the data which I have. So this technique, this is, please listen, this technique can be used in machine learning method and process and to get the speaker identification or the speaker authentication or the speaker verification. As I said that if you download the data from TEDx or different channels, you can see that the different person speech on YouTube or these TEDx on several places. If you download that data and to process the data is enough, the inference, whatever the knowledge that will be inferred from this data in middle point, whether data and the next one is the high performing computer, the network. Network means high. The IBM has a supercomputer. CDAC has also a supercomputer, and several company also has supercomputer. So in between, one is data, and in between the high power network, and to get the behavioral nature or some of the algorithm, and the output will be given, and the output will be given by the all the sequence. In short, I can say that, but I cannot say that. In future, linguist or phonetician won't have any role. Sorry, so I cannot, but sometimes I have to say that. Even some of the computer science also, same thing happened for this. So no, that is somehow it is not at all right. I told you that language change, ideology change, and the knowledge resource, and knowledge resource will be in the hand of human being, and the language will be in the hand of human being, and the generation to generation, the language will be handed over to other generation. It will run. It will run as much as possible. I hope that. So the second point, which I like to mention here, that forensic phonetics and intonation. Glad Folk, a famous acoustic phonetician, and you can read so many books from him, mentioned that speech is not the same as language, because speech carries the information of the speaker identity and it reveals his social status. Speech is different, and it carries the social identity. Suppose if my mother, my mother and father passed away. Okay, suppose one person's mother call you through mobile phone or phone, everything, you can easily detect that. Easily you can detect that is my mother. Same as the father. If father or mother, if you call from little distance, not even use the mobile phone or computer, whatever maybe. So if the little distance, if they speak, and if they call your name, you can easily identify their voice. That a particular feature, that is very complex things. I cannot also explain what is it. That is a complex things in the brain, what a neural process, how the neuron passes this information to dendron, axon, and the different level. How so many people know the concept behind that, the processing of brain, processing of suppose if we hear the voice and it will go through the ear and it will vibrate through that, and it will pass over to the dendron, neuron, and several section, and then only we can easily understand that that voice or speech and everything. So that is the thing. If we this complexity, but technique is come, technology is come, human is studying about human brain with his own brain, and the group of humans, the group of humans, they study about brain with their own brain. I hope that is the 1% result won't come. That is not possible. So that forget out that. So this is the forensic phonetics as well as the forensic speech technology also nowadays support the criminal procedure by giving scientific evidence of acoustic analysis. This is one important area is the forensic phonetics. The forensic phonetics, as I mentioned that these phonetic features, especially an expert phonetician and acoustic phonetician, nowadays with the help of the speech scientist or speech expert, can easily identify who spoke to someone, or the voice is the identity of the voice is his own, or that is it is easily identified. So again, I came to the single point that which is the most important feature, the intonation pattern and the pitch. The intonation pattern or the tone and intonation is enough to recognize the voice of a person. And that is somehow I can tell that intonation is, or the pitch variation is enough to determine the speech of a speaker, and also used for the speaker identification. So simple, I already mentioned, so many people discuss about this one, machine learning and neural network. This is the audio wave is there, and the spectrum and the spectrograph features will be extracted through this different algorithm, deep learning algorithm, or CNN, convolutional neural network, and extract, and the residual CNN. This CNN, so CNN is on, and it will get the feature maps. And this technology and the machine learning and this technology can be useful for speaker identification technique. So I made a statement here. I feel that it is required. Relevance of acoustic phonetics and the survival of the fittest. I mentioned that acoustic phonetics has so many opportunities. So many opportunities. Phonetics also. But the survival of the fittest. One is the employment and another one is the unemployment. Introduction of linguistic subject in the degree level. The linguistics or acoustic phonetics or phonetics, speech technology and computational linguistics, everything. It is like to addicting the liquor or cigarette or something like that. If you get the knowledge, if you get PhD, if you get postdoctoral fellowship, well, a postdoctoral degree, and to be MA and MPhil, if you addict to this subject, you love this subject. It is very difficult to avoid this subject. It is not possible to alienate from this subject. The subject is like that. We sometimes we won't get food, sometimes we won't get a job, sometimes we won't get professorship or associate professor or something, whatever maybe. But if you addict to this subject, you cannot retrieve from this addiction. That is the power of this linguistics and acoustic phonetics and phonetics and other. But the survival of the fittest and Charles Darwin evolution theory, that also I need to mention here that if the linguist or computational linguist or the computer scientist, speech scientist, or maybe, if they want to survive in this, in India or abroad or anywhere, they need to get the employment. So my suggestion to the art student, my suggestion to all the professors, the respected professors, scholars, that, and please introduce this linguistic subject in the degree level. Somebody will be benefited and they will get the teaching position on some other job. That is my request. Then these are the things. So at the same time, the plus point is that survival of the fittest means linguistic people, the competency is very less. And the computer science or other subject, the competency is more. So even the technological giant and everything, they need to survive. Who is fit enough to the universe or earth, they will survive. Otherwise, whichever the creature, they won't survive in earth. So this is my request, that introduce the linguistic subject in the degree level. So again, come to the second point, language and a human being. So I mentioned about the Charles Darwin evolution theory, and language plays a significant role even at the time of human evolution. Language plays a significant role even at the time of human evolution. So to get a dark age data of language, that is not possible. But the human has the capability, human has the capability to exchange his ideas, to exchange his emotion, everything through the language, not like other creatures. So what I mentioned here, that there are several applications in applied linguistics, especially these forensic phonetics, biolinguistics, neurolinguistics, psycholinguistics, forensic linguistics, computational linguistics, sociolinguistics, everywhere. So Chomsky, you see that Chomsky left out syntax. Now his most of the study is based on this biolinguistics area. So same as the neurolinguistics area, the neurologist, and they also need the linguistic person. Same as the case of the psycholinguistics person. It is same for forensic linguistics. The importance of this subject is that's what I mentioned here, that there are several opportunities for linguists. So the one important thing is that it is not possible to unify two linguists, because it is what's a debatable subject. If Chomsky made the concept, or Panini made the concept, or the Kerala Panini made the concept, or Tolkappiyar made the concept, and there will be some debate between these linguists. That is language. But in case of computer science or mathematics, a plus b the whole square is equal to a square plus 2ab plus b square, or 4 plus 5 is equal to, or 4 plus 4 is equal to 8. If you make the computer program also, if something for loop or something it is wrong, or something is not things, it will get the error. But language is entirely different. And as I mentioned, that language came with a human being. After that only all this technology came, especially this computer and this speech recognition, or this acoustic phonetics, or everything. So I conclude here with a statement with the last word. Tamil en உயிர். தமிழ் மொழியும் என் உயிர். தமிழ் மொழியலும் என் உயிர். If you can go ahead with Tamil and Tamil linguistics, you can reach the zenith of this knowledge. Thank you very much. If anybody has any question, please. Okay, thank you.
Okay. Dr. Banish has clearly articulated that how the linguistic science, especially the phonetics or acoustic phonetics, are relevant for working on speech technology. And because he has taken sample from Malayalam and Tamil, and of course he has given a lot of ideas over the use of linguistic science for doing research on speech technology. And finally, he concluded that the linguistic science is a must study subject. It must be introduced in the UG level too. Oh, such a wonderful presentation. Now the floor is open for discussion. People who wish to express their view, and rather people who wish to clarify their own doubts can express their view. Now floor is open.
Manish, a very nice talk. Actually, I really enjoyed it, and you have really told about the positive attitude or positive nature of the linguistics in the speech technology. But still, no, I have a kind of negative attitude towards linguistics because I'm here in Ahmedabad University. I mean, once actually I was made use of till 2017. No, I was made use of when machine learning was in practice. Okay, and they used to come to me and something they write about the language based on the linguistic analysis. Then they train their system, the machine learning approach, and they come out with something. But when the deep learning and the neural work come, they totally discarded us. They totally discarded me. Especially phonetic, the speech actually become more of what you call physics rather than linguistics actually. So that actually, I don't know how far we can contribute on the speech technology because technology people know they don't do it. They want to do it with linguistics to be frank enough. They want to learn Panini or Apiyam or Kerala Panini or whatnot actually. And they with corpus, you yourself is a corpus driven actually. So somebody said about corpus driven. So when huge corpus is there, when the parallel corpus is there, and you can annotate phonetically or or phonologically or whatever it may be, then by making use of the machine technique method, you will be able to get the output. I think Google do the same thing actually. It's not actually, I don't know whether Google has got any linguists actually who really do some contribute to their technology actually. They have got a very good translator. They have got a very good OCR system. They have got a very good girls text to speech, speech to text system. That of course they rely on the neural network or statistical analysis. And I don't know how much of actually linguistic. Okay, thank you.
Thank you, Professor.
Thank you, sir. What you said is correct, sir.
Mr. Bani,
Yes.
thank you that you've taken very nice subject and it's a nice presentation. I have seen you in a different form there some few years ago. The first time I see you face to face, otherwise I have seen I evaluated your thesis submitted to
Yes,
the
sir.
Kerala
Thank you,
University,
sir. Thank you very much.
and I know that most of the things you have done in the thesis only, the examples and everything. I just wondered the way you have done it. Okay. Your talk highlighted the relevance of phonetics and acoustic phonetics, especially in the modern time, in different aspects of language like speech recognition, forensic linguistics, and other things. And you explained with your own ideas and thinking also. Yes, you suggest that linguistics is very important and indispensable in today's work on speech recognition and even speech synthesis, speech technology, etc. But I have to share Professor Rajendran's view also. It's more of physics than the linguistics like that. So we are only the language data provider, and they are the one way of doing it and achieving the target. So that can't be avoided. I don't know whether it can be avoided in the future also. That is one thing. It's a very nice presentation, I must admit that thing. And some clarification I want to put for the purpose of the audience also. When I talk about the phonetics and the acoustic phonetics in the title, then the audience should not think both are separate things, because when we say phonetics, it includes articulatory, acoustic, and auditory phonetics also. But we wanted to highlight the relevance of phonetics in
Acoustic
general,
phonetics, yeah.
as well as the acoustic phonetics in particular domain. Also, we use the word intonational phonology,
Phonology.
and also you have the word suprasegmental phonology. Both are interchangeable terms only.
Yeah.
Okay. When you talk about suprasegmental phonology, it is a very complex feature. It is very difficult to work also. It involves many features, many systems, and intonation is not a kind of
Alone, yeah.
is like a glottis between the vocal cords. It's not an organ, but it is there and it is important for speech production, glottis. Like that, intonation is not there, but it is created by different systems. So that's why Abercrombie says that intonation is a system of systems. Okay, it is a pitch system, pitch level system, tempo system, duration, rhythm system, etc., all combined to form intonation like that. Okay, so that is I want to clarify this thing. Both are interchangeable terms only, and also. Yeah, there are a lot of things to talk about intonation, which is not possible for you to say within that short time. So congratulations, but your ideas and presentation should be realized by the audience and other experts in the field of linguistics and computational linguistics and even computer scientists also. Thank you for your nice presentation. Thank you.
Thank you, sir.
Thank you, sir. What
Thank you.
What you mentioned is correct. The suprasegmental feature, intonation is come under the suprasegmental features. At the segmental level, that is very difficult to process that the suprasegmental features, rhythm, pattern, and intonation is also part of
One of
this
the
suprasegmental features. That's one.
one of the
So
features.
so several things are related to the suprasegmental feature. My state of mind, if I speak
Stress,
any different
intonation.
Yes.
emotional things, that will also change and several things, the rhythm, speech pattern, and yes, 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 sir. That is the things. Yes. Thank you, sir. Thank you very much.
Thank you.
Okay. Thank you. Thank you.
Thank you. Thank you, sir. Thank you. We sincerely thank Dr. Banis Narayana Pillai for his wonderful lecture. So thank you very much, sir. Thank you very much. Now,
Thank you, sir. Thank you very much.
Now let us move on to another lecture. And in this lecture, Mr. Nichal Karan, because Nichal Karan is going to deliver a lecture. His name otherwise known as Raja Ram. Okay, he will be talking about the sentimental analysis tool for Tamil language. He will be delivering a lecture spanning with regard to the general Wikipedia also. He will be talking. Okay, let us listen.
ஓகே, நன்றி, வணக்கம். என்னுடைய திரையை பகிர்றேன்.
ஓகே, உங்களுடைய வீடியோ தெரியல.
என்னுடைய திரை தெரியுதுல?
திரை தெரியவில்லை. இப்போ தெரியுது.
வணக்கம். சொல்லப்போனால் நான் வந்து 2 தலைப்பையும் தயார் பண்ணியிருந்தேன். சென்டிமெண்ட் அனலைசிஸ்க்கும் பண்ணியிருந்தேன், அதே மாதிரி வந்து ப்ரோக்ராமிங் இன் ஸ்பீச் டெக்னாலஜி 2க்கும் தயார் பண்ணியிருந்தேன். நான் அதை அப்படியே தொட்டிட்டு அப்படியே விக்கிபீடியாவுடைய இதர இதை நான் அடுத்தடுத்து சொல்ல நான் பார்க்குறேன். ஒரு 20 நிமிடங்களுக்குள்ளே முடிக்கலான் இருக்கேன். நான் அந்த நேரம் தான் எனக்கு கொடுத்த நேரம்னு நினைக்கிறேன். சரி, இப்போ ஸ்பீச் டெக்னாலஜியில் எப்படி ஒரு ப்ரோக்ராமராக நம்ம எப்படி பயன்படுத்தலாம், அதில் என்னென்ன வசதிகள் இருக்குது, என்னென்ன ஃபங்க்ஷன்ஸ் மாடியூல்ஸ் இருக்குது அப்படின்றத நான் வந்து இன்னைக்கு அடிப்படையாக சொல்லலான்னு பார்க்குறேன். முதலே நான் வந்து ஒரு டிஸ்க்ளோஷர் கொடுத்துட்றேன். நான் வந்து ஒரு லிங்குவிஸ்டிக்ஸ் கிடையாது. ஸோ அதனால் வந்து ஒரு லிங்குவிஸ்டிக் பார்வையில் அல்லது வந்து ஒரு மொழியியல் கருவி சார்ந்து இதில் இருக்கக்கூடிய நுட்பங்கள் பற்றி எனக்கு பெரிய அளவில் பதில் இல்லாமல் கூட போகலாம். ஆனால் ஒரு நிரலாளராக, ஒரு ப்ரோக்ராமராக என்னென்ன வகையில் நம்ம பயன்படுத்த முடியும், எங்கெங்கெல்லாம் இருக்குது அப்படின்றத பற்றி சொல்லலாம் அப்படின்னு நான் பார்க்குறேன். நமக்கு நேற்றைய அதுக்கு முன்னாடி அமர்விலே வந்து நமக்கு இந்த பற்றின ஒரு அடிப்படை ஒரு புரிதல் வந்திருக்கும். என்னென்ன மாதிரியான கருவிகள் இருக்குது அப்படின்றத பற்றி தெரியும் உங்களுக்கு. ஜீபோர்டாக இருந்தாலும் சரி, அல்லது வாய்ஸ் டைப்பிங், இதை பற்றி ஏற்கனவே தெரிஞ்சனால வந்து இதை வந்து நான் ஸ்கிப் பண்ணிடுறேன். ஆனால் இது என்னென்னா, இப்படி ஒரு கருவிகள் இருக்குது. இந்த கருவிகள் வழியாக குரல் வழியாக நம்ம உள்ளீடு செய்கிறோம் அப்படின்றத நம்ம புரிஞ்சுக்கிறோம். அதே மாதிரி உரையில இருந்து ஒலி மாற்றி பண்ணக்கூடிய நிறையா கருவிகள் இருக்குது. குறிப்பாக வந்து இந்த எஸ்என் கல்லூரியிலேருந்து பண்ண இந்த கருவியாக இருந்தாலும் சரி, இல்லை டாக்குஃபை, ரீட் அலவுட் அப்படின்லாம் பார்த்தீங்கன்னா மைக்ரோசாஃப்டுடைய வேர்ட்லேயே பிளகினாக கொடுத்துருப்பாங்க. இது எல்லாமே வந்து தமிழுக்கு ஒத்திசைவு இருக்குது. இது மட்டும் இல்லாமல் தமிழில் ஒத்திசைவு, தமிழுக்கு இணக்கமாக இருக்கக்கூடிய ஒரு மென்பொருட்கள் அப்படின்னு பார்த்தீங்கன்னா ஒலி சார்ந்த தொழில்நுட்பத்தில் சுமார் ஒரு 37 மென்பொருள் திட்டங்கள் இருக்கு. சில திட்டங்கள் நிறைவடைந்து பயன்படுத்தக்கூடியதாக இருக்கும். சில திட்டங்கள் ஒரு நிரல் வடிவில் இருக்கும். அதை நம்ம எடுத்து கொஞ்சம் மேம்படுத்தி நமக்கு வேண்டிய வகையில் பொருத்தி பயன்படுத்துகிற மாதிரி இருக்கும். இருந்தாலும் என்னென்ன முயற்சிகள் இருக்குது அப்படின்ற ஒரு தொகுப்பு இங்கே வந்து அவங்க காட்டக்கூடிய எழுத்துக்களை நம்ம உச்சரித்து நம்ம வந்து ஒலிக்கொடை கொடுக்கலாம். அதாவது ஸ்பீச்சை வந்து நம்ம கான்ட்ரிபியூட் பண்ணலாம். அதே மாதிரி வந்து அவங்க காட்டக்கூடிய இமேஜ், அந்த படத்தை பார்த்து நம்ம தட்டச்சு செஞ்சும் கொடுக்கலாம். அடிப்படையில் அவங்க என்ன செய்யறாங்கன்னா, ஒரு ஒரு இந்திய மொழிகளுக்கான ஒரு தரவுதளத்தை வந்து உருவாக்குறாங்க. எல்லா விதமான தரவுதளமும், டெக்ஸ்டா இருந்தாலும் சரி, ஸ்பீச்சா இருந்தாலும் சரி, இல்லை இமேஜ், இந்த மாதிரி பலவற்றுக்கும் அவங்க உருவாக்குறாங்க. இதை யார் வேணா பங்களிக்க முடியும். இந்த பங்களிப்புகளுடைய தொகுப்பு நம்ம இங்கே பார்க்க முடியும், basni.gov பார்க்க முடியும். அதே மாதிரி இன்னொரு குறிப்பிட்ட ஒரு தரவு தொகுப்பு பார்த்தீங்கன்னா openslr.org வந்து தமிழுக்குன்னு ஒரு செட் இருக்கு. ஒரு அதிகமான ஒரு கோப்பாக அது இருக்கு. அதை எடுத்து நம்ம வந்து ஏதாவது பயிற்சிகளுக்கோ அல்லது பயன்படுத்திக்கலாம். அது போக உலகம் முழுக்க இருக்கக்கூடிய ஒரு பெரிய ஒரு ஃபவுண்டேஷன், அதாவது நான் ப்ராஃபிட்டபிள் ஃபவுண்டேஷன் பார்த்தீங்கன்னா மோசிலா. விக்கிமீடியாவுக்கு அடுத்து, அதாவது விக்கிபீடியா திட்டங்களுக்கு அடுத்து பார்த்தீங்கன்னா மோசிலாவை தான் நம்ம குறிப்பிடும். அவங்க வந்து பொதுக்குரல் திட்டம் அப்படின்னு சொல்லி ஒரு திட்டத்தை வந்து அறிமுகப்படுத்தியிருக்காங்க. நிறைய பேர் அதை பற்றியும் கேள்விப்பட்டிருக்கலாம். சமீபமாக கூட நம்ம அதிகமான பயிற்சிகள் கூட பொதுக்குரல் அப்படின்ற பேரை நம்ம நடத்தியிருப்போம். இப்போ இதில் பார்த்தீங்கன்னா இதுலேயும் அதே மாதிரி வந்து தரவுகளை வந்து சேமிக்கிறாங்க. நம்ம பொதுமக்கள்கிட்ட இருந்து இப்போ ஒரு சொல் காட்டுவாங்க, அந்த சொல்லை நம்ம வந்து உச்சரிச்சோம்னா அந்த உச்சரிச்ச அந்த சொல்லை வந்து அவங்க வந்து சேமிச்சு வச்சுருவாங்க. பின்னாடி நமக்கு யாரோ ஒருத்தவங்க தமிழ் சார்ந்து தேடுறாங்கன்னா இப்போ அவங்களுக்கு இந்த மாதிரி கிடைக்கும். இப்போ பாருங்க, இதெல்லாம் மீது தமிழ் சார்ந்த இத்தனை கோப்புகள் இருக்கு. இதை நம்ம எடுத்து நமக்கு தேவையான பயிற்சிகளுக்கோ அல்லது ஆய்வுகளுக்கோ நம்ம தாராளமாக பயன்படுத்திக்கலாம். இதுல குறிப்பா சொல்ல வேண்டியது வந்து இது எல்லாமே வந்து CC0, அதாவது கிரியேட்டிவ் காமன்ஸ் 0 அப்படின்ற உரிமத்துல கொடுத்துருக்காங்க. அதனால நம்ம தாராளமாக நம்ம பயன்படுத்த முடியும். எந்த ஒரு காப்புரிமை மீறலும் இங்க நிகழாது அப்படின்னு நான் சொல்றேன். இது ஒண்ணு. அடுத்து இன்னொரு இந்திய அரசினுடைய இன்னொரு தளம் இங்கே இருக்கு, ராஸ் ஸ்பீச் கார்பஸ் சொல்லி. இது பொதுவாக கல்வியியல் துறையில் இருக்கவங்களுக்கு இதை பற்றி தெரிஞ்சிருக்கும். ஐடிசிஐலோட ஒரு கார்பஸ். இதுலேயே நீங்கள் இந்திய மொழிகளுக்கு நிறைய இதுக்கு பார்க்கலாம். அடுத்து முக்கியமான எந்திர வழி கற்றல்களுக்கெல்லாம் பார்த்தீங்கன்னா அதிகமான அந்த தரவு தொகுப்பெல்லாம் சேமிக்கக்கூடிய ஒரு இடம் பார்த்தீங்கன்னா ஹக்கிங் ஃபேஸ் அப்படின்னு சொல்லுவோம். இப்போ இந்த தளத்தில் போய் பார்த்தீங்கன்னா எக்கச்சக்கமான கார்பஸ் இருக்கும். ஒரு மொழிக்கு மட்டும் கிடையாது, எக்கச்சக்கமான மொழிகளுக்கும் இங்கே கொடுத்து வச்சிருக்காங்க. இந்த ஹக்கிங் ஃபேஸ் அப்படின்றதே வந்து ஒரு ரெபாசிட்டரி மாதிரி. உங்களுக்கு ஏதாவது டேட்டா செட் இருக்கு அப்படின்னா நீங்க இங்கே ஏற்றலாம். அதே மாதிரி உலகம் முழுக்க பெரிய பெரிய அமைப்புகள்லாம் வந்து அவங்களுடைய டேட்டா செட், அந்த தரவு தொகுப்பு வந்து இங்கே சேர்த்திருப்பாங்க. இப்போ அதில் பார்த்தீங்கன்னா அதில் தமிழுக்கான ஸ்பீச் டேட்டா செட்டும் இதில் இருக்கு. அப்போ இதையும் நம்ம தாராளமாக எடுத்து பயன்படுத்திக்க முடியும். இதில் இந்த ஹக்கிங் ஃபேஸோட ஒரு முக்கியத்துவம் என்னன்னா, இதுலேயே நீங்கள் நிரல் எழுதியும் நீங்கள் இயக்கி பார்த்துக்க முடியும். ஒருவேளை உங்களுக்கு பைத்தான் இந்த மாதிரியான மொழி தெரிஞ்சிச்சுன்னா நீங்கள் இங்கேயே இயக்கி பார்த்து அந்த தரவுதளத்தை எடுத்து பயன்படுத்தி நீங்கள் பயன்படுத்திக்கலாம். ஹக்கிங் ஃபேஸ் மாதிரியே இன்னொன்று கேகிள் அப்படி ஒரு தளம் இருக்கு, கேகிள்.com சொல்லி. கேகிள்லையும் இந்த மாதிரி டேட்டா செட் கிடைக்கும். ஆனால் அது அதிகமாக பார்த்தீங்கன்னா அது டெக்ஸ்ட் சம்மந்தப்பட்ட அதிகமான தரங்கள் வந்து அதிகமான தரவு வந்து கேகிளில் இருக்கும். கேகிளும் ஹக்கிங் ஃபேஸும் வந்து ஒரு முக்கியமான ஒரு தொகுப்பு, அது பொதுவாக இருக்கக்கூடிய ஒரு தொகுப்பாக நீங்கள் பார்க்கலாம். அடுத்து இன்னொரு வந்து பார்த்தீங்கன்னா வானொலி நிலையத்தினுடைய ஒரு தொகுப்பு இங்கே இருக்கு. இதெல்லாம் எதுக்கு காட்டுறேன்னா, ஒருவேளை ஆய்வு செய்யக்கூடிய மாணவர்கள் அல்லது வெறும் உரை ஒளி மாற்றி மட்டும் இல்லாமல் வெவ்வேறு நிலையில ஆய்வு செய்ய நினைக்கிறவங்களுக்கு வந்து இந்த மாதிரியான தரவுகள் உங்களுக்கு பயன்படும். அதற்காக நான் இங்கே காட்டுறேன். அடுத்து ஒரு முக்கியமாக என்னென்ன இந்த மாதிரியான தொழில்நுட்பங்கள் நிரல் வடிவில் இருக்கு. நம்ம இதுக்கு முன்னாடி இப்போ 2 நாள் ஏற்கனவே நிறைய பேருடைய அனுபவங்களை நம்ம பார்த்துருப்போம். அவங்களுடைய ஆய்வுகள் எல்லாமே வந்து ஒரு ஒரு முழுமையான படைப்பாகவோ அல்லது வந்து ஒரு பொதுவான ஒரு தியரி ஓரியன்டாக இருக்கும் வச்சுக்கோங்க. இப்போ உங்களுக்கு உண்மையிலே ஏக்கி பார்க்கணும், எனக்கு வந்து நான் வந்து பேசணும், நான் பேசினா அது தமிழில் தட்டச்சாகுமா அப்படின்னு கேட்டிங்கன்னா, அப்போ அதுக்கு நமக்கு உடனே என்ன தேவைன்னா நமக்கு நிரல் தான் தேவை, அந்த ஒரு கோடிங் தான் தேவை. அதற்கு பிறகு நம்ம வந்து கோடிங்கை நம்ம கற்றுக்கிட்டு கூட அந்த மாற்றங்கள் பண்ணுவதும் நம்ம செஞ்சுக்கலாம். இப்போ நல்ல உதாரணம் சொல்லுவாங்க, இப்போ நீங்கள் சைக்கிள் ஓட்ட கற்றுக்கணும்னா நம்ம அதுக்காக சைக்கிளோடைய மெக்கானிசம் அதை படிச்சுட்டு தான் சைக்கிள் ஓட்டணுன்றது கிடையாது. நம்ம நேரடியாக அந்த இருக்கையில் உட்காந்து நம்ம இடுப்பை வளைக்காமல் ஓட்டி பழகிட்டு அதற்கு பிறகு தான் வந்து அதில் இருக்கக்கூடிய மெக்கானிசத்தை நம்ம கற்றுக்குவோம். அந்த மாதிரி கூட நீங்கள் அதை எடுத்துக்கலாம். அப்படி பார்த்தீங்கன்னா முக்கியமாக சில இந்த எஸ்டிடி அல்லது டிடிஎஸ் இது சார்ந்த சோர்ஸ் கோட் இருக்கக்கூடிய தளங்களை இங்கே கொடுத்துருக்கேன். அதில் ஒரு சோர்ஸ் கோடை வந்து கடைசியாக நான் பயன்படுத்தின கோடில் எப்படி நான் அந்த நிரல்கள் எழுதியிருக்கேன் அப்படின்றத அடுத்தடுத்து நான் காட்டுறேன். அதற்கு முன்னாடி இதை பற்றின சின்ன அறிமுகம் கொடுத்துட்றேன். இப்போ இதில் பார்த்தீங்கன்னா ஓப்பன் டிடிஎஸ் அப்படின்றது வந்து உலக மொழிகளில் நிறைய மொழிகளுக்கு வந்து உங்கள் ஒத்துசேவை கொடுத்துருக்காங்க. நீங்கள் இங்கே போய் பார்க்கலாம். இது குறிப்பாக பார்த்தீங்கன்னா எம்ஐடி லைசன்ஸ். அப்போ இது வந்து ஒரு பொது உரிமத்தில் இருக்கக்கூடிய ஒரு திட்டம் தான். இதில் தமிழுக்கான ஒத்துசைவும் இருக்குது. இது எந்த அளவுக்கு தமிழில் வந்து சிறப்பாக செயல்படும் அப்படின்றதுக்குள்ள நான் போக விரும்பல. ஏன்னா அது வந்து இவங்க எப்படி பயிற்சி கொடுத்துருக்காங்க அதை பொறுத்து இது ஓப்பனாக இருக்கனால இப்போ நீங்களே உங்கள் தரவை கொடுத்து நீங்கள் இதை பயிற்சியும் கொடுத்துக்க முடியும். ஆனால் என்ன புரிஞ்சுக்கலாம்னா, இந்த மாதிரி ஒரு ஓப்பன் டிடிஎஸ் அப்படின்ற ஒரு மாடியூல் இருக்குது. இந்த லைப்ரரியில் போனீங்கன்னா உங்களுக்கு தேவையான ஒரு வசதியை நீங்கள் பயன்படுத்திக்கலாம். இப்போ உதாரணத்துக்கு நீங்கள் ஒரு இணையதளம் வடிவமைக்கிறீங்க, அந்த இணையதளத்தில் உங்களுக்கு வந்து இந்த மாதிரி டிடிஎஸ் வேணும், டெக்ஸ்ட் டு ஸ்பீச் வேணும். ஒரு உதாரணத்துக்கு தமிழில் இருக்கக்கூடிய ஒரு செய்தித்தளமாக வச்சுக்கோங்க. அவங்களுடைய செய்திகள் அப்படியே வந்து ஒலி வடிவில் கொடுக்கணும்னா இப்போ நீங்கள் இங்கே போய் பார்த்தீங்கன்னா உங்களுக்கு அந்த நிரல் கூட காட்டும். அதை நீங்கள் போட்டு தமிழுக்கு இது ஒத்திசைவு இருக்குது, நீங்கள் அதை எடுத்து பயன்படுத்திக்க முடியும். அதே மாதிரி வந்து இந்த கல்வி ஏஎஸ்ஆர் அப்படின்ற தளமும் பார்த்தீங்கன்னா தமிழுக்கு ஒத்துசைவு இருக்குது. இவங்க ரெண்டுமே பண்ணுறாங்க. எஸ்டிடியும் இருக்குது, டிடிஎஸும் இருக்குது. அப்புறம் இஸ்பீக் அப்படின்றது வந்து ரொம்ப காலமாக இருக்கக்கூடிய ஒரு மென்பொருள். இதையும் நீங்கள் எடுத்து பயன்படுத்தி பார்க்க முடியும். அப்புறம் முக்கியமாக இந்த P5 அப்படின்றது வந்து போன ஆண்டு நான் வந்து இந்த மென்பொருளை வந்து ஒரு பள்ளிக்கு நான் வந்து ஒரு கருவி உருவாக்கி கொடுத்துருந்தேன். இது வந்து பார்த்தீங்கன்னா P5 அப்படின்றதே வந்து ஒரு ஜாவா ஸ்கிரிப்ட்ல இயங்கக்கூடிய ஒரு மாடியூல். அதில் நீங்கள் தமிழில் பேசிட்டீங்கன்னா தமிழுக்கு அதை புரிஞ்சு கொண்டு தமிழில் தட்டச்சு செஞ்சு இது கொடுக்கும். இது ஒரு ஜாவா ஸ்கிரிப்ட்னால உங்களுக்கு பெரிய அளவில் ஒரு எந்திரங்களோ அதுவோ தேவையில்லை. நீங்கள் சின்னதாக வந்து ஒரு சின்ன கோப்பில் HTML ஃபைலில் நீங்கள் எழுதினா கூட உங்களுக்கு இது வந்து உச்சரித்து காட்டும். துல்லியம் வந்து அந்தளவுக்கு இருக்காது. ஆனால் அடிப்படையில் வெறும் குறைந்த நிரலாக்கத்தில் நீங்கள் உருவாக்கணும்னு நினச்சிங்கன்னா இந்த P5 பயன்படுத்தலாம். இதுக்கு வந்து இணைய இணைப்பு தேவையில்லை. அது இல்லாமலே நீங்கள் பயன்படுத்த முடியும். அதே மாதிரி இது டெக்ஸ்ட் டு ஸ்பீச், இது நிறைய பேர் கேள்விப்பட்டிருக்கீங்க. முனிவர் வாசு ரங்கநாதனுடைய தளம். இதனுடைய நிரலும் அப்படியே இருக்குது. இது வந்து PHPயில் உருவாக்கியிருப்பாரு. PHPயில் நீங்கள் அந்த நிரலை நீங்கள் முழுக்க பார்க்க முடியும். நீங்கள் அதையும் மேம்படுத்தி நீங்கள் பண்ண முடியும். அதே மாதிரி வந்து துவானி அந்த மாதிரி, அப்புறம் அரிமா, டிடிஎஸ் இந்த மாதிரி எல்லாம் இது எல்லாமே ஓப்பன் சோர்ஸாக இருக்குது. டெக்ஸ்ட் உங்களுக்கு அதாவது அந்த சோர்ஸ் கோடை வந்து நீங்கள் விஷுவலாக நீங்கள் பார்க்க முடியும், நீங்கள் திருத்த முடியும். அப்புறம் முக்கியமான வேறு சில தளங்கள் இருக்குங்க, டீப் ஸ்பீச்சு, தமிழ், இது எல்லாமே வந்து சோர்ஸ் கோடோட கொடுத்துருக்காங்க. இது வந்து இந்திய அளவில் இருக்கக்கூடிய AI4 பாரத் அப்படின்ற ஒரு குழு, அந்த குழுவினர் வந்து இந்திய மொழிகளுக்கு எல்லாத்துக்கும் பண்ணுறாங்க. அதில் தமிழுக்கும் எடுத்து பண்ணியிருக்காங்க. இதில் போனீங்கன்னா இங்கே தமிழுக்கான அந்த எப்படி அவங்க பண்ணியிருக்காங்க அப்படின்றத நீங்கள் பார்க்க முடியும். அக்யூரசி வந்து நீங்கள் இதில் போய் பார்த்தா தெரியும். அதை பற்றி நான் சொல்ல விரும்பல, ஆனால் இந்த மாதிரி ஒரு முயற்சி இருக்குது அப்படின்னு நான் சொல்கிறேன். சரி, இப்போ அடுத்து வந்து நம்ம நிரலாக்கத்துக்குள்ளே போவோம். அடிப்படையில் வந்து அதிகமாக இணையத்தில் பயன்படுத்தக்கூடிய தளம் பார்த்தீங்கன்னா விண்டோஸ். நம்ம தளம் கிடையாது, அதிகமான ஓஎஸ் அப்படின்னு பார்த்தீங்கன்னா நம்ம விண்டோஸ் தான் அதிகம் பயன்படுத்துவோம். அதனால் விண்டோஸில் இருக்கக்கூடிய 2 மாடியூல், அந்த 2 மாடியூல் எடுத்து நான் செஞ்சு காட்டலான்னு பார்க்குறேன். உதாரணத்துக்கு முதல்ல பார்த்தீங்கன்னா ஸ்பீச் சிந்தசைஸ் அப்படின்னு சொல்லி ஒரு மாடியூல் இருக்குது. ஒரு மாடியூல் இது பொதுவாகவே எல்லா விண்டோஸ் கணினிலையும் இருக்கும். நீங்கள் ஒரு விண்டோஸ் கணினியில் ஒரு 10 விண்டோஸ் 10க்கு மேலே பார்த்தாலே இந்த மாடியூல் இருக்கும். இதை வந்து நீங்கள் C# இந்த மாதிரி விண்டோஸுக்கான விஷுவல் ஸ்டுடியோ மாதிரியான மென்பொருளில் கூட நீங்கள் பயன்படுத்திக்க முடியும். நான் வந்து சின்னதாக வந்து ஒரு ஜாவா ஸ்கிரிப்டில் எடுத்து இதில் பண்ணுறேன். இப்போ இதில் பார்த்தீங்கன்னா இங்கே இந்த மாதிரி தான் வந்து அந்த மாடியூலை வந்து நீங்கள் கூப்பிட்டுட்டு அதுக்குள்ளே என்ன வார்த்தையை நீங்கள் வந்து உள்ளே அனுப்புறீங்களோ அந்த வார்த்தையை இங்கே கொடுக்கலாம். இப்போ நான் வந்து வணக்கம் அப்படின்னு கொடுக்குறேன். கொடுத்ததுக்கப்புறம் என்ன வாய்ஸ் அப்படின்றத நீங்கள் கொடுப்பீங்க. இந்த ஸ்பீச் சிந்தசைஸ் மட்டும் பார்த்தீங்கன்னா ஒரு 30 40 அந்த ரேஞ்சில் தான் வந்து மொழிகளை வந்து ஒத்திசைவு இருக்குது. அதில் எந்த மொழி அப்படின்றத வந்து இங்கே கொடுக்குறோம். நமக்கு வந்து TA-IN நினைக்கிறேன் அந்த கோடு இங்கே வரும். அதை இங்கே எந்த மொழின்னு கொடுத்துட்டு அப்புறம் நம்ம வந்து பிச்சோட வேல்யூ நம்ம மாற்றிக்கலாம், அதே மாதிரி ரேட்டோட வேல்யூ நம்ம மாற்றிக்கலாம். இவ்வளவுதான். இந்த முக்கியமா இந்த 6 வரிகள் தான் முக்கியமானது. அதற்கப்புறம் வந்து பொதுவாக அந்த பேஜுக்கான அந்த பக்கத்துக்கான சில கூடுதல் நிரல்களை நம்ம பயன்படுத்துவோம். ஆனா இது மட்டும் இருந்தா போதும். இது வந்து உங்களுக்கு வந்து ஒலிக்கீற்ற மாத்தி கொடுக்கும். அப்ப வணக்கம்ன்ற சொல்லை வந்து நீங்க வந்து உச்சரிச்சு கேட்க முடியும். இதுக்கு வந்து இணைய இணைப்பு தேவையில்லை. ஒரு பொதுவான ஒரு விண்டோஸ் கணினி மட்டும் இருந்தா போதும். அதுல வந்து இந்த ஸ்பீச் சிந்தசைஸ் வந்து வேலை செய்யும். 1. சரி, இது வந்து நீங்க டெக்ஸ்ட்டை வந்து அந்த ஒலியா மாத்துறீங்க, சவுண்டா மாத்துறீங்க. இதே இது வந்து அப்படியே ரிவர்ஸ்ல பார்த்தீங்கன்னா ஸ்பீச் ரெகக்னிஷன் சொல்லுவோம் பார்த்தீங்களா, அதுக்கான மாடியூல் பேர் பார்த்தீங்கன்னா வெப்கிட் ஸ்பீச் ரெகக்னிஷன் அப்படின்னு சொல்லுவோம். இதுவும் மைக்ரோசாஃப்டோட தான். இது வந்து இன்னும் உங்களுக்கு அதிகமாக பயன்படும். நிறைய பேர் டெக்ஸ்ட்டை ஸ்பீச்சை மாற்றுறதை விட ஸ்பீச்சை தான் டெக்ஸ்ட்டாக அதிகமாக பயன்படுத்துவாங்க. நம்ம பேசி அதை வந்து அந்த கட்டளைகளை புரிஞ்சுக்கொண்டு அதில் நடக்கணும்னு நினைப்போம். இப்போ அது பார்த்தீங்கன்னா கொஞ்சம் வித்தியாசமாக இருக்கும். அது நம்ம வந்து இந்த மாதிரி முதல் ஆரம்பிப்போம், அந்த ஃபங்க்ஷனை போட்டு ஆரம்பிப்போம். அதுக்கப்புறம் அதோடைய தொடர்ந்து பேசுகிறதா இல்லையா அப்படின்றத நம்ம அந்த ட்ரூவா ஃபால்ஸை நம்ம செட் பண்ணுறோம். அப்புறம் எந்த மொழி அப்படின்றத இங்கே செட் பண்ணுறோம். அதுக்கப்புறம் பார்த்தீங்கன்னா 2 ட்ரிகர்ஸ் இருக்கும். 2 ட்ரிகர், ஒன்று அது வந்து தொடங்குறதுக்கு, இன்னொன்று வந்து நிறுத்துறதுக்கு. அதை நம்ம வந்து ஸ்டாப் எங்கே வேணுமோ அதை நம்ம கொடுத்துக்கலாம். சில சமயம் ஒரு பட்டனில் வைக்கலாம். அப்போ பட்டனை அழுத்துனா அது வந்து தொடங்கும், அதாவது நம்ம பேசுகிறத கேட்க தொடங்கும். அதே பட்டனை திருப்பி அழுத்துனா அது நிறுத்திடும். இந்த ஸ்பீச் ரெகக்னிஷனோட அடுத்து முக்கியமானது பார்த்தீங்கன்னா அது நம்ம பேசுகிற ஒலியை வாங்கிடுச்சு, அதை ப்ராசஸ் பண்ணி எப்படி கொடுக்கணும் அப்படின்னு பார்த்தீங்கன்னா 2 இது இங்கே முக்கியமானது பண்ணுவோம். ஒன்று ஆன் ஸ்டார்ட், அது எப்போ தொடங்குதோ அப்போ வந்து நம்ம ரெகக்னிஷனை வந்து ட்ரூன்னு கொடுப்போம். அதுக்கப்புறம் அதே மாதிரி எப்போ எண்ட் ஆகுதோ அப்போ ஃபால்ஸ் கொடுத்துருவோம். ஏன்னா அது இல்லாட்டி நம்ம யதார்த்தமாக பேசக்கூடியதோ அல்லது வந்து பேக்ரவுண்டில் இயங்கக்கூடியதோ வந்து அது வந்து கேட்டுக்கிட்டே இருந்து ப்ராசஸ் பண்ணி நமக்கு எழுத்துக்களாக கொடுத்துக்கிட்டே இருக்கும். அதனால் வந்து நம்ம எண்டும் ஸ்டார்ட்டும் ரொம்ப முக்கியம். அதற்கப்புறம் இது 2 முடிஞ்சதுக்கப்புறம் தான் ஆன் ரிசல்ட் அப்படின்னு சொல்லி ஒரு சின்டெக்ஸ். இந்த சின்டெக்ஸில் தான் உங்களுக்கு வந்து அதனுடைய பதில் கிடைக்கும்.